Hello everyone, I'm Firyuza and you are watching the channel Bold Science with Firyuza. In 2019, the world was shown an image that was called the shadow of a black hole. A circle, blurry, orange, with a black spot in the middle. It was presented to us as a victory of general relativity. But today, we will do something very different. We won't look at a drawn image. We will look at reality, at what is actually happening at the center of galaxy M87, and why this very galaxy calls the very idea of black holes into question. M87 is not just one of many galaxies. It is a giant elliptical galaxy located in the Virgo cluster. It is the center of the local supercluster of galaxies. Galaxy M87 has a mass of roughly 1 trillion solar masses. Its diameter is about 140,000 light-years. At its center there is a supermassive compact object. But that is not the main point. The main point is what emerges from this center. From the core of M87 emerges a colossal relativistic jet, a stream of plasma extending for tens of thousands of light-years. In optical wavelengths, we see about 5,000 light-years, in the X-ray range up to 30,000, and in the radio range up to 100,000 light-years. This image is taken from open NASA ESA sources, the Hubble Space Telescope. This is not a trick. This is a cosmic phenomenon. The central jet of galaxy M87 is one of the most powerful known in the universe. The power of the relativistic jet in galaxy M87 is estimated to lie between 10 to the 35th and 10 to the 38th watts. This value is obtained from analysis of radiation mechanisms and the interaction of the jet with the surrounding medium using radio synchrotron models and numerical simulations. Let us take the average 10 to the 37th watts. We will treat this value as an approximate power of the outflow. For comparison, the power output of the Sun is about 3.8 times 10 to the 26 watts. The M87 jet is roughly 25 billion times more powerful. This is the power of the entire Milky Way galaxy focused into a narrow beam. One may ask, what is the temperature of the jet? The jet is relativistic plasma ejected from the center of the galaxy. Different regions emit in different ranges, from radio to X-rays. This radiation is non-thermal, so we are not talking about the true temperature, but about the energy of electrons expressed in temperature units. Radio emission is produced by electrons with energies equivalent to millions of kelvins. Optical emission corresponds to electrons with energies of tens and hundreds of millions of kelvins. X-ray emission is associated with electrons whose energies are equivalent to billions of kelvins. And here we come to the key problem, and a question arises that almost no one asks. According to some estimates, the mass of the visible part of the jet is about between 10 to 30 and 10 to the 4th solar masses. This estimate is based on the assumption that the jet contains no matter other than plasma-emitting synchrotron radiation. If, however, the jet also contains heavy particles or weakly radiating matter, then the true mass of the jet may be several orders of magnitude higher. It should be noted that the calculation covered only the inner optically visible luminous part of the jet with a length of about 5,000 light-years. The full extent of the M87 jet is above 20 times larger, roughly 100,000 light-years. Therefore, the total mass of the entire jet is approximately 20 times greater than the lower estimate of the mass of its visible part and may reach values of about 2 times 10 to the 5th solar masses. And this is a minimum, assuming that the jet contains no non-radiating or weakly radiating matter. If we consider the currently popular accretion model of black hole activity, then an enormous amount of matter must have fallen into the center of galaxy M87, more than the mass of the entire jet. That is more than 100,000 solar masses. But elliptical galaxies, including M87, are almost devoid of gas, are almost devoid of dust, contain no visible matter other than stars. In such galaxies, there is simply nothing to fall into the center. Even if galaxy M87 once had matter capable of falling directly into the center, it would have done so long ago. Could a globular star cluster have fallen into the center of M87? The average mass of a globular cluster in galaxy M87 is about 300,000 solar masses, but the size of a globular cluster is tens of light years, and the average distance between the stars even in the core of such clusters is about 0.04 light years. That means the distance between stars is roughly 100 times larger than the capture cross-section of a black hole. At best, one star would fall in, the other would pass by. It is impossible to explain a powerful jet with a mass of 100,000 solar masses in this way. There are only two fundamentally different scenarios for the origin of the jet. The first, the jet is emitted by the object itself, without any accretion onto it. The second, the jet is formed from matter outside the event horizon that somehow ended up there. But the second scenario runs into the absence of matter, and the first runs into a fundamental problem. According to general relativity, an isolated black hole cannot emit anything. If there is a black hole at the center of M87, then the matter of the jet must first have fallen into the center before being ejected from it. But in galaxy M87, there is nothing that can fall into the center. The mass of gas near the supermassive object at the center of galaxy M87 is estimated, according to various data, to range from a few to several tens of solar masses. These values are obtained from radio interferometric observation and X-rays measurements of the density of hot gas in the central region of the galaxy. Even if all of this gas were to fall onto the object, it would not be able to produce even a small fraction of such a jet. Therefore, according to all black hole models, such a jet simply cannot exist in galaxy M87. But it does exist. It is long-lived, stable, colossal. This is not a minor inconsistency. This is a fundamental contradiction. The M87 jet falsifies the accretion model, falsifies the black hole hypothesis, demonstrates that a different physical mechanism operates at the center. The center of M87 we see a compact, ultra-energetic object ejecting matter, but not consuming it. This is not a voracious black hole. This is an active energy source whose nature has not yet been determined. And that is precisely why the black hole at the center of M87 is not a triumph of general relativity, but its exposure. If a theory fails to explain an observation, it is not the observation that is at fault. The M87 jet exists, it is real, and it demands new physics, not new images. You have been watching the channel Bold Science with Firyuza. Subscribe so you don't miss the next videos, and see you in the upcoming episodes.